Hello and welcome to this video on how to divide polynomials. There are two types of divisions that could occur when dividing polynomials. The first thing that could happen is you could have something that looks like this. 20x to the 8th minus 15x to the 6th plus 30x to the 5th, all divided by 5x cubed. In this situation, we have a polynomial on top. This is a poly on top. It's got three terms. And on bottom, it is a monomial. It only has one term. And if you're only dividing by one term, then that's one of the easier ones. And basically, we've written a procedure over here to help you with it. Basically, if you're dividing by a monomial, like this problem here, you're going to take each term on top and divide it by the monomial on bottom. So let's write that out. Here I'm going to take this 20x to the 8th and divide it by the 5x cubed. I'm going to do the same thing with the second term. Minus 15x to the 6th divided by the bottom term. Plus 30x to the 5th all over 5x cubed. Notice that I took each of the terms on top and I'm dividing it by the monomial on bottom. Now I'm going to divide these. We divide by dividing the numbers, the big numbers, like normal. 20 divided by 5 is 4. And with the little numbers, remember what the exponent rule is that when we divide exponents, you subtract the numbers. So 8 minus 3 would be 5. Again, divide the bigs. 15 divided by 5 is 3. And subtract the smalls. 6 minus 3 is 3. Divide the bigs. 30 divided by 5 is 6. Subtract the smalls. 5 minus 3 is 2. That's the process of doing that one. Let's have you try one. Actually, let's have you try two really quick. The first one we're going to have you do is 32x to the 8th minus 40x to the 7th. And I want you to divide that by 8x to the 5th. Give that one a try. And I'd also like you to try another one. Let's go with 16x to the 20th minus 4x to the 8th plus 2x to the 4th. And we want you to divide that by 2x to the 4th. Go ahead and pause the video now and work on dividing these polynomials by the monomial on bottom. Okay, let's see how you did. I need to divide each of the tops by the bottom. So I'm going to move this over so I have a little more room. So I'm going to divide the 32x to the 8th divided by 8x to the 5th minus 40x to the 7th divided by 8x to the 5th. I'm dividing each of the top terms on top by the bottom. Now let's divide. 32 divided by 8 is 4. And x to the 5th divided by, or x to the 8th divided by x to the 5th would be x to the 3rd. We subtract the exponents. 40 divided by 8 is 5, and it'd be 7 minus 5 is 2. So that's our answer for that one. Same thing here. I would divide each of the tops. 16 divided by 2 is 8. With the bottoms, I'm going to, with the little numbers, we subtract, so it'd be 8x to the 16th. 4 divided by 2 is 2x to the 4th because we subtract these exponents. And here we have 2 divided by 2, which is 1. And notice the x's would just cancel out. X to the 4th divided by x to the 4th, well, that's just 1. Or x to the 0, which is 1 as well. And so that would be our answer. Okay, that's the first type of problem. It is possible to divide a polynomial by another polynomial. Notice that we have a 3-term polynomial divided by a 2-term polynomial. In this situation, you can't do what we did in these first types of problems. It's a different type of problem. We need to use what is called long division. Now we're going to do exactly what you used to do way back in the day with a problem that actually I'm going to pull this over here. With a problem like a normal long division problem. For example, if I told you to take 122 and divide it by 5. We're going to compare these two problems and actually do them the exact same as you would way back in the day when you did long division. So, first step for long division, would be to put this number into the box. We put the top number into the box, so it's 122 divided by 5. That's the first step. We're going to do that over here as well. It's going to be the top number goes in the box. I then ask myself, I look at these first numbers here, and I divide as much as I can. 12 divided by 5 is 2. I do the same thing here. I take this first number and divide it by the first term of the polynomial. I'm just dividing by the first term. So x squared divided by x, well, that would be when we divide powers, we subtract the exponents, it would just be x. So again, we took 12 divided by 5, and we said the answer was 2. Here we took x squared divided by x and got x. I need a little more room here. Move these up. Okay, good. The next step then we do is we say 2 times 5 is 10. I would do that here as well. X times x is x squared. We also need to do it to the 2. So x times 2 is 2x. When we do this problem over here, the next step in long division is to subtract. And I'd put a minus here at this 10. So that's what I need to do here. I need to subtract all of this. So I'm going to put this is going to become minus, and the 2x will also become minus because we're subtracting the value. 12 minus 10 is 2. Remember, you did this way back in the day, probably 3rd or 4th grade. We're doing the same thing. I'm going to add these together now. So here I did 12 minus 10, that's 2. Here I get x squared minus x squared, well, that's just gone. And 7x minus 2x, well, that's 5x. Back in grade school, we then told you to bring the number down. Bring the 2 down. Here we're going to bring the plus 10 down. And we're going to divide all over again. I say 22 divided by 5. 22 divided by 5, well, that is 4. I'm going to do that here as well. Here I have a 5x, and 5x divided by x, 5x divided by x, well, that's just 5. So I put a plus 5 because we're dealing with polynomials. We then multiply this number through. 4 times 5 is 20. 5 times x plus 2 would be 5x plus 10. We then subtract the value out, and here I'm left with 2. That's our remainder. Here I subtract this out, and I'm left with 0. There is no remainder, and so my answer is x plus 5. And that's how we divide out polynomials, using long division, just like you did in 3rd or 4th grade, except it's a little more complicated because there's a bunch of x's and stuff like here. But the process is the same. Let's have you guys try 2 problems of long division. Good luck. Okay, so here are 2 long division problems to give you some practice. Go ahead and pause the video now, and when you're ready to check your answer, you can unpause and we'll see how you did. Okay, let's take a look. I'm going to go ahead and put x squared plus 12x plus 20 into the box here, and we're dividing it by x plus 2. Okay, so we need to take the first 2 numbers and divide them together. So I'm taking this one, x squared, and dividing it by x. X squared divided by x is just x. We then multiply this x to the 2 values on the outside, giving us x squared plus 2x. We're going to subtract these values, because that's what we do in division. When we subtract these, they're gone. When we subtract these, I'm left with 10x, and I bring down the plus 20. We're going to divide again. I'm going to take this 10x and divide it by the other x. 10x divided by x, well, that's just 10. So I'll put plus 10 for my answer. And 10 times x is 10x. And 10 times 2 is plus 20. When we subtract these out, we get a 0, which means it goes in evenly. And our answer then is x plus 10. We're going to do the similar steps here. X plus 1 divided by, or actually it's 2x squared plus 5x plus 3 divided by x plus 1. We're going to take the first numbers and divide them. So 2x squared divided by x. 2x squared divided by x is just 2x, because one of the x's cancel. So I write 2x here. We're going to multiply the 2x through our outside values. 2x times x is 2x squared. And 2x times this 1 is plus 2x. We're subtracting. When we do that, we're left with 3x, and we bring down the 3 here, so plus 3. We'll then divide the outside numbers again. 3x divided by x. Well, the x's just cancel out. That leaves me with 3. And we'll multiply the 3 to these two values out here to get 3x plus 3. And when we subtract, once again, we're left with no remainder. And so my answer on this long division question is 2x plus 3. Thanks for watching How to Divide Polynomials. Keep working hard.